everyone, and welcome to this video instruction on landing gear for the Airbus A320 and family. This is produced by Operation Aviation. We are going to have 6 sessions under landing gear. Session 1 is going to be an overview and including the maintenance related systems and functions that help with resolving the faults. Session number 2 is landing gear indicating and warning. Session 3, extension and retraction, and that includes the free fall extension. Session 4, main landing gear. Session 5, nose landing gear. And our last session, session 6, is wheels and brakes. Let's go ahead and start with session 1. This is an overview of the landing gear for the Airbus A320, and also I'm going to go over the maintenance related systems. But I want to bring in a story to begin with. It's not going to be really a story, just going to reference an actual accident regarding the landing gear. It was Scandinavian Airlines Flight 1209 on December 9th of 2007. And this is an example of failed right main landing gear that was due to maintenance procedures. The investigation revealed that the right landing gear hydraulics actuator eye bolt was separated from the actuator. Also, they found corrosion on the inside, which of course reduced the mechanical strength of the actuator. So just giving you kind of an awareness from and we're going to hear from Rick at some point about some mishap with landing gear. So the importance of maintenance, of course, is critical. And as far as just an overview, we have 2 main landing gears, and for each of those landing gears we have 3 related doors, and 1 nose landing gear and related doors, 2 extension and retraction systems, the landing gear, wheels, and related brake systems. And by the way, the wheel systems are twin wheels, nose landing gear steering system, and I want to go into detail a bit more about the LGCIUs, which are the landing gear control and interface unit. Okay, so as you know, the landing gear absorbs energy and supports that aircraft upon takeoff, taxiing, and landing. So of course it's important to have all the components and systems functioning properly. We're going to go ahead and get into the functions of a lot of the systems pertaining to maintaining the components, etc. Let's start with the control system for the main landing gear. These are the LGCIUs, okay, the landing gear control and interface units, and there are 2 of them, and they're comprised of hardware and software in order to consistently monitor for faults that are going on. The units are also able to send, and they do send, any fault information to other systems of the aircraft as needed. It also has a bite test, and as well as it simulates the different positions of the landing gear. You can also run it on the ground and do the system tests. The LGCIUs that detect faults, they do that by either passive or active checks with its built-in test functions. And that affects the LGCIUs, following outputs of discrete status and indication, as well as your selector valve solenoid control outputs, and also outputs from the ARINC 429. So what are some of the faults that it can detect? Well, it can detect proximity sensor and wiring failures. It can also detect proximity sensor and target unreasonable failures, discrete input failures, configuration pin programming failures, selector valve solenoid failures, and selector lever failures. So when it's detecting all of this, where does this data go? Well, from here it's going to go to the CFDS, which is your centralized fault display system. And what does that comprise of? Well, you have a couple of things. Well, you get a couple of main parts. You have the centralized fault display interface unit. Okay, that's your CFDIU. And then you have 2 other units. These are the multifunction control and display units, your MCDUs. And just so you know, the CFDS is considered a maintenance aid system, so that's pretty important. The byte, of course, the byte is software, and that's going to be monitoring different things, your proximity sensor inputs, your control logic, your control lever inputs and also electrical power supplies. A better way to describe the byte for the Airbus A320 is it operates in different phases, or just in different ways. One would be during an initiated test. Okay, another one would be after all the resets. Another is after a power reset only. That's the only thing you're doing is a power reset. And the other is continuously. There's also a control fault. And this is important to note. It's a confirmation control fault, but it's a control fault that affects the control of the landing gear and doors. So if there is something wrong, with that, then it's going to essentially disable those circuits because it doesn't want to have something defective trying to control the operation of the landing gear and the doors. Okay, so it's a confirmation fault that when that shows, then it's going to disable those driver circuits. Okay, on the byte, you have to make a test selection on the MCDU, okay, your multifunction control and display unit. The test is a process that operates most of the circuits, and it's going to basically, it doesn't operate the solenoid driver of the selector valves or the control lever because it's trying to prevent movement of those. The byte, as far as the length of time before it stops and finishes, is 7 seconds. All right, and during the byte test, what different things are going on. The Novel RAM keeps all the failure data. Okay, the LGCIU transmits incorrect landing gear position information. Also, there's a software failure monitor function that continues to operate. And when that's doing that, the hardware function is not operating. At the end of the byte, you're going to see a message on the CFDS, and that's going to be either test OK, or when it's done, it's going to be test OK. And it's going to be sending that to the CFDIU. And then also, of course, if there's any failure data, it's going to send it to the Novel RAM in the memory. So all of the faults are, being watched during different cycles. Basically, what the computer is doing, it's sifting out the faults that are necessary and those that are not. So, you can recover some faults in the test time until it's confirmed as an actual fault. So even though it's gathering all that information, it's going to sift through that and then decide which ones are really, really a fault, and those will show up. Okay. And the fault is recorded if it's not recovered before the set time in the byte. So that's going to be there in byte memory. And there's a subset of faults. A subset of faults is corrected when they're confirmed. So it's going to be, kind of an automatic resolution, if you will. And so when that fault gets confirmed, it's going to stay in that recorded byte memory. The maintenance data will continue to be transmitted to the CFDS, and after it's recovered, if the same fault is reconfirmed during that same flight, the occurrence count for that fault will be incremented. Okay, so it's going to add it, add one more if it shows up again after it was, after it was resolved. Okay, what about the failure data? A little bit more on failure data. The software is going to make sure that the failure that's found is correct. Okay, you don't want to have something showing and it's nothing wrong, but it's showing that there is a fault. But so what it's doing is when that's done, when this is done, when it's completed, the isolation and failure filtering. Okay, remember what I was saying? It's going to be sifting through the different faults. So if a failure occurs when airplane's in flight, then the data is going to go into that flight memory. That is going to keep that data. And as far as the capacity of that flight memory, that's going to be up to 30 failures. So just so you know, that might be a test question, but 30 failures is the max capacity for that flight memory to store. Okay. Each of the entries can be kept in the memory for a maximum of 64 flights. Okay, data can be up to 64 flights automatically. If once it reaches that, it automatically erases at the start of the subsequent flight. Okay, so it's whatever was there, and it passes the 64th flight, then it's going to get rid of that information. Okay, the data for a certain failure only goes into that memory once during each flight. Okay, so You have that. If there's an intermittent failure during that time when the plane's up in the air, then it's going to put that data into the memory the first time that it fails. It's going to count the number of times that it happens again, and it's going to, of course, it's going to put that count value into the memory. There's also different classes. This is an in-flight class 3 failures, zone 5. For the class 3 faults, there's a byte memory zone 5 that stores that data as different things. It's going to be fault code, your SRU code, flight phase during which the fault was first found. So it's going to record that information, the date and time that it was found, and the kind of the frequency of that same fault. Your class 3s are removed from the memory again at the subsequent engine start. So it's going to, in this particular case, it's going to be at subsequent engine start that it erases all of that. Okay, what about a simulation function? We do have this here with the Airbus. It's the landing gear simulation function. I'll talk a little bit more about it in a little bit, but it's a maintenance aid. Okay, this is another aspect to the maintenance systems that exist on the Airbus to help technicians, diagnose and troubleshoot and be able to resolve some of this stuff. So that's there. You're able to do a simulation without having to do any physical, basically set it up, if you will. You don't have to do that. You're able to do a simulation in order to run tests and troubleshoot, with that. So during the simulation of it, what's happening? You're going to have the LGCIU that supplies the output data that's going to agree with the simulated configuration. Okay, and it's not going to be correct. Obviously, you're trying to troubleshoot. Also, the ARINC 429 and discrete signals go to the applicable interface systems. Now, the CFDS, okay, your centralized fault display system, has two modes. It has a normal and a menu mode. And your normal mode is going to be continuously monitoring for failures. That's normal. The menu mode is only available on the ground. Okay, when plane on ground, that's when you can operate the menu mode. You cannot operate it in flight. The MCDU, okay, is set for the 2 units. Okay, the 2 units. When that's set, then the applicable LGCIU sends a menu of the failure data and test items to this MCDU. Now, what are you going to see on that LGCIU menu? Okay, in this menu mode. Okay, you're going to see different things. You're going to see a ground report, and I'm going to go over this in a little bit with each one, just kind of touch on them. But you have your ground report, the class 3 faults, the landing gear simulation, test, ground scanning, troubleshooting data, the LRU identification, and you have your previous and your last leg report. Okay, so those are the items on the menu mode. All right. Okay. So let's talk a little bit about the last leg report. You're going to see that on the display. The display is going to show the failure messages. Again, all that information is being kept in the novel RAM during the last flight. Okay, that's the last lag, right? So it can show a maximum of 2 failure messages at one time. It can show more failure messages when you use the next page key. So, there's a next page key on that, just so you know from a functional standpoint. Of course, that'll have no effect if there's the one page is showing all of the faults that it found. Previous leg, you also have the previous leg report, and this one is kept in the novel RAM during the last 63 flights. So that's a lot of information, over the course of 63 flights previously, okay, that the leg report will be showing. At the top, there's going to be there's a last message kept shows first, and then each page of the display is shows 2 failure messages. Okay. Again, next page key is there for you to use. All right. So you have those 2. Okay. Now your ground scanning function is just a procedure to access data related. with the faults that are currently active. Okay, so that's what that's for. So for example, when a fault is found, and not just found, but after it's done its shifting, it's going to say, okay, this is a definite fault. Then the data related with the fault, it's not kept in the LGCIU byte memory. It will be available to, for display on the ground scanning page. So anything related to that, when it does find it, just so you know, it will be found on the ground scanning page, but it's not going to be kept in the LGCIU byte memory. Okay. Now the test, remember I mentioned to you earlier, the test, there's a test selection that you make on the MCDU, and when you select it, it's going to say test wait, and then it goes for about 10 seconds. And then the next 10 seconds, then that's when the byte does the test. And then when it's done, you could have different indications. It'll say test OK, or it could be test, and then it's going to, the CFDS failure indication on there and the message end of test will show. Okay, a little on the landing gear simulation. This is, again, just a helpful aid for maintenance. With this here, you have displays that are going to show, and the different things you're going to see here are going to be different configurations. For example, one of it's going to be nose, just nose by itself, and you're also going to have, nose left hand or nose plus right hand, or the combination, where we have both of those with the nose, the left and right hand, and then a combination of left hand and right hand. So those are the different ones you'll see or can see as far as configurations on the display. And then also when you make a selection from that display, the display changes to one which gives different positions. Okay, you've got your up locked, right, down locked, your extended and compressed. So those are other other display words that you're going to see. There's also an arrowhead shape that's adjacent to the indications for the positions that are not held by the landing gear. Okay, so it shows that a simulation of these positions can be made. Okay, so for example, if you have the nose landing gear is locked down and compressed, okay, so then you have compressed landing gear position, and then you have an arrow extended, can be simulated. Okay, down locked is landing gear position, and then an arrow up locked can be simulated. Okay, ground report, this gives the failure messages that are stored, okay, gives those stored in the byte LGCIU memory, and for those failures that occur or have occurred, when the plane actually is on the ground. So that's why it's called ground report. Of course, it has the function key for next page, so you have the same setup there, as far as you're able to manipulate, switching from one page to another. So you have that as well. Okay, so it kind of gives you an idea with the maintenance systems and, an overview of what we have as far as a number of main landing gear systems and your nose landing gear, etc. But there's a lot of different tools here for doing the testing, and to make sure, those, faults are being detected, and then after those faults are go through that first phase of detection, and it's going to sift out and really determine, whether or not something is an actual fault. All right, so let's go ahead and do some knowledge checks, and then we'll be moving on to our next session. All right, so just a few there, and of course your handout, remember I said just refer to it, but I'm going to just mention some here. On question number 1, how many landing gear control and interface units does the Airbus landing gear control system have? Is it 2 or 3? Okay, it's 2. There's 2 units. Each LGCIU cannot run a byte test. Is that true or false? It's false. Okay, each LGCIU keeps fault data as well as send the data to other aircraft systems. Is that true or false? Okay, it's true. All right, what kinds of fault conditions can the LGCIU detect? Priority valve solenoid failures, pin programming failures and proximity sensor failures, or configuration pin programming failures, selector valve solenoid failures, and discrete input failures. Okay, so ladder. What is considered a maintenance aid system? The CFDS or the ECAM? Okay, so CFDS. Okay, the bit operates intermittently as needed. Is that true or false? Okay, the answer is false. It actually does it continuously. Okay, remember there's different, we're talking about bit, we're talking about, built-in test, and there's different phases at which you can do that, so that's the bit. What are the two kinds of checks in which faults can be found? Is it normal and alternate, or passive and active? Okay, it's passive and active, right? Okay, the LGCIU has a built-in test failure that prevents it from operating the landing gear and doors if in the event the LGCIU is defective. What is this called? Okay, because it has its own built-in for itself. Okay, so is it confirmed control fault or control effect? Okay, it's confirmed control fault. Okay, let's go to number 14. The menu mode is available both in flight and on the ground. Is that true or false? Okay, it's false. I said it's ground only. Okay, number 15. Continuous failure monitoring is always available, including when in menu mode. Is that true or false? Okay, it's false. So it's not in menu mode that you have continuous. Okay, monitoring. Okay, so number 16, the previous leg report will show failures of the last how many flights? 56 or 63? Okay, I mentioned before it was 63, right? Okay, and there's the other questions on there that you can refer to, but I wanted to go over some of them so you kind of get your mind there and start thinking about some things that you want to keep in your head or take notes about. All right, this concludes our session 1 on landing gear for the Airbus A320. We will be continuing on with our next session. We are on now to session 2 on landing gear indication and warnings. And what we're going to see here is some of the indications that are on certain displays. We have the different components that are involved in the indicating and warning are going to be your proximity sensors. This is going to be also indication for the doors, not just the landing gear, but also the doors. The ECAM DUs, in particular, we're talking about the wheel page that's going to show up. And then the central warning system as well, and also the landing gear control lever and indicator lights. So let's kind of get into a little bit on the displays that we have. If there's going to be any indication for position of the landing gear and doors, warnings, for example, any faults that are going to show up, they're going to be going through, from the proximity sensors, and then that is going to be an output to the LGCIUs that goes to the flight compartment on the ECAM display units. So we have that process. The ECAM, we have the wheel page, which, by the way, it just automatically shows when you have the first engine start up until the first engine gets to takeoff power. That's actually going to show. It's an automatic display. And also the landing gear is in the down, or if at 1600 feet radio altitude, whichever comes first until the second engine shut down. So those are the conditions in which you have that automatic display of the wheel page of the ECAM system. Now, as far as the central warning system, because that's going to show positions, the central warning system is going to be obviously showing, what failures are existing. You're going to have a couple of different things with the central warning system. You do have aural as well as visual equipment in order to be able so the flight crew can know what fault is going on. So the functions here, obviously position indication, the data is going to be to different systems, and then the warnings and the cautions are going to show up, okay, with the master caution light, etc. Okay, so that's what you have. And we're going to talk about the little, as far as the types of the lights or indicators that are on here. So with the, when we're talking about the nose landing gear and each of the main landing gear, they're separated as far as their proximity sensors, so they can be, right, so we can know, from which one has a problem, or we want to be able to know the position of it. Those are both green lights, by the way. And then when we look at the downlock indicator lights, those show the position, and they're going to show in two parts. You've got the color green and red. Okay, so it's green and red colors. The bottom half is going to show in the color green. And then that's for if the landing gear is in downlock position. Now, if it's not in the selected position, then it's going to show a red, and that's going to be in the top half. And then if the position is that landing gear is in uplock, then there's not going to be any lights at all. Okay, that's for that. And then cautions and warnings that you're going to see that will automatically show up if there's a problem is you're going to have landing gear system disagree, landing gear or LG gear uplock fault. You also have not downlocked, not uplocked, not closed, and you just have on each of the systems there could be a fault, so that will show up as well. Your landing gear control lever has a down arrow light, and the light's going to come on if you have two things going on. The aircraft is in a landing configuration, or the landing gear is in a not locked down position. Okay, so remember I was mentioning about, okay, let's look at the actual indications. What do they look like? When you bring up the ECAM, you're able to bring up the ECAM wheel page, you're going to see 3 sets of indicators on here that are going to show triangles, and those are, there's the triangles, and then there's also a moving hinged bar, and that's just going to show the door position. Okay, the triangles can those can be in green, red, or not lit up at all. If there's no color at all, then it's not in view at all when there's an up and locked position of the landing gear. Now, if it's in transit, that landing gear movement is in transit, then it's going to show in a red, so the triangle is going to be a red. And then of course the landing gear, remember, anything that's down and locked is going to be green. So down and locked for landing gear is green. Okay, that's important, obviously, when we're talking about being in a landing configuration for the aircraft. So, and then back to, and so with the hinge bars, those are the triangles, but then you have the moving hinge bar. So, what's this about? We're talking about the, the doors. So, amber's not closed, green means they're closed. Okay, so that's, pretty straightforward there. Okay. And then you have also system warnings. There's different ones that you'll see on the EWD that are going to show up kind of automatically. Landing gear not down locked, not up locked, and you can kind of review some of those. But you got up lock fault, system disagree. Some of the things I mentioned earlier, those are going to show up on the engine warning display, or EWD. Okay, for that, and then also. Yeah, the other thing to be aware of, besides the triangles and the moving hinged bar, is X legends. So you're going to see X's that are going to kind of replace door indicators, essentially. So those will show up, when there's certain failures. They're going to show up in amber on the wheel page of the ECAM. And as far as the position indicating light units, those are on the 402 VU panel. The panels, that's actually on the main instrument panel above the control levers, where you'll find that. And so those indicator lights are going to be in red and green. Okay, green, remember, green is always down and locked. So that shows that. Okay, and just, when are you going to have the warning message? Obviously in flight. If you're going to have, if one of the units fails, okay, so that if one of those LGCIU fails, then you're going to have a warning message show up. And also, if it occurs in, you know, in the actual sensing system. Okay. Now, there's also a shock absorber fault. You know, it's important to obviously make sure that there's enough shock absorption, and that that's, you know, the right amount in that, obviously, for handling the energy upon impact, upon landing, and also upon takeoff, right? So those are going to show. Those are also the X legends, X's that will be there, and those will be in the amber color. All right. Also, there's after the flight, after the aircraft is in phase 5, and 2 seconds after that, there's going to be that message on the shock absorber fault. So if there's a problem, that's when it's going to show up, and it's going to be obviously the master caution lights are going to come on, and in this case, there's also going to be a sound. So there's a chime that comes on as well when there's a problem with the shock absorber. What about the landing gear not down locked, or not up locked, or the door's not closed? If you have one or more of the doors, you know, not locking in the right position, then you're going to have a message that's going to show. Okay, and that wheel page is going to show that. Okay, that's going to show up. Actually, it's going to be in view if that happens. Okay, so if you have a message like let's say landing gear not down locked or not up locked, okay, and that shows up on the wheel page, because when that happens, the wheel page, remember I said there's only a window in which the wheel page actually shows up. Otherwise, it's not going to. But this is another instance where it will. Then there's going to be the message LGCTL, which is your control, and then there's going to be the red triangles. So red's not the good thing. You got 2 red triangles that are going to show at the whatever's, you know, whatever one is not working right. It's going to be associating with that indication position. Okay. You also have, you know, we're talking about, let's kind of go over just a few configuration warnings. Okay, so let's say you have the configuration of landing gear not down. Okay, then you have the FWCs and the ECAM are going to be supplying that configuration warning, LG not down. Okay, and it's going to be using System 1 and System 2 landing gear control and interface, okay, LGCIU to show that warning. Also in the FADEX, okay, and also the slat and flap. So the different areas where you're going to see this, you know, warning come about is in also the slat and flap instrumentation position pickoff units, your IPPUs. Okay, so if you ever see IPPU, that's what that is. Okay, instrumentation position pickoff units, and then also from the radio altimeters. Okay. So, with, you know, when the aircraft's in one of those configurations, okay, then the things that are going to start happening is you're going to have the red master warning lights come on. There's going to be a repetitive chime going on. There's going to be a message, a warning message coming on that shows landing gear knocked down on the upper, it's going to be in the upper ECAM, and then you're also going to have a red down arrow on the control lever itself. So that's going to be different from, you know, just having that down arrow not illuminated. But if there's a problem, then it's going to be showing in red. Okay. Also, the warning of not down is going to happen when you have the landing gear that's not locked down, and you have just one LGCIU that's serviceable. That's 2 conditions, okay? And then also, let's say that the aircraft is below 750 feet radio height with the engines not at takeoff power, okay? And then you have different conditions that can be possible. One, you could have an engine below 97% RPM with the other engine master control switch in the off position, or you could have both engines below 75% RPM. Okay, so with those conditions, and then, you know, one of the LGCIUs is serviceable, meaning one is not, then you're going to have a warning. Okay. The other thing too, the aircraft is below 750 radio height with different other conditions. This would be having to do with the flap position, because remember I mentioned the IPPU, which is in relation to slat and flap instrumentation. So here there's another condition where we're not talking about the engines now in relation to that, we're talking about flap position. So with here, if the flap position and slat position is 18 degrees or larger on the flap and 16 degrees or larger on the slat position, okay, and engine's not at takeoff power, okay, or aircraft is in flight phase 6 with 2 not serviceable radio altimeters. So these are just different conditions where, you know, you're going to have that warning of landing gear not down. The other warning, the other configuration you could have here is an uplock fault. So this is going to show if, you know, system 1 and 2 is picking up that the uplock has closed when the landing gear is downlocked. Okay, so what happens when that's the case? Well, the master caution lights are going to come on. That's going to be an amber, okay, and then they're going to have that sound, the chime that comes on, and that's when the wheel page is going to actually show up in view, and you'll see that. So, okay, and then also I mentioned about systems disagreement. If you have okay, the ECAM system that's going to compare, okay, right, the data from system 1 and 2. It's going to make that, look at that to see what differences there are. And if there's a difference, then it's going to give a warning on that wheel page. And that's going to be the landing gear, or is it LG sys disagree. So that's the way it's worded on there, and that indicates, obviously, that's the fault. When you have one of the two systems is detecting some mechanical failure, whether it's in the door uplock or, you know, landing gear uplock or downlock, then what's going to show? You're going to have the wheel page is going to come on. Okay, it's going to be an amber, and then you're going to see the word uplock, and then 2 X's. Okay, if either one of the systems is giving signals to the ECAM, okay, that you have the uplock being closed when the MLG or the NLG is in downlock position, or you could have it where the landing gear is in locked down, but the MLG and NLG is, you know, locked, or they're locked up. So there's another condition there. About free fall extension, this is another one, another configuration. So with landing gear free fall extension, normally you're gonna have a green position indicator. The lights, those are gonna come on, and you know, that would be fine. But if it doesn't show, you know, as you have the free fall extension that's happening, then it's going to take about 30 seconds before the wheel page is going to actually show automatically. And then on top of that, you're going to have green triangles that are going to show up in view. And the doors fully open or landing gear doors and transit indications are going to show as well. Okay. The other things too, just a last thing to mention, the other couple of possibilities you could have on the display is going to be max speed 250 and the landing gear not closed. Okay, those are the other ones you will see on there. Okay, so let's kind of give you an idea on really the wording that will show up on the display units, and obviously the information going from the proximity sensors to the LG CIUs in order to transmit those signals to the flight compartment. Okay, so obviously to the ECAMs and your CWS and all that. So, you know, again, the triangles are what indicate, you know, if the green is good. So if we have a different color, amber obviously, you know, and red, those are going to be different conditions than the desired position. So that's kind of, you know, kind of a rundown on those. So let's just kind of go over some knowledge checks, nothing extensive. I'll just kind of mention a few things here. But number 18, what is the function of the indicating and warning system of the landing gear? Okay, we're talking about position and warning data, right? Okay, that's the answer. All right, and then number 19, what is shown on the wheel page of the ECAM system as it relates to landing gear indicating a warning? Your two choices are position of the landing gear and its doors, or position of the brakes. Okay, well, we're talking about landing gear and doors, so that's position of landing gear and doors. Okay, let's try, okay, question number 21. What color indicator light is the one for landing gear downlocked? Okay, is it red or green? Okay, it's green, right? Okay, and the ECAM wheel page has how many different sets of colored indications? And by the way, this had actually 3, so your choice is a 2 or 3. Okay, I just gave you the answers. Actually, there's 3 sets of those indications, the ones that are colored. Okay, question number 26. The hinged bars on the ECAM wheel page indicate whether or not the doors are closed. Is that true or false? Okay, it's true. All right, and then the green indicator lights mean what? Landing gear is up locked or landing gear is down locked? Okay, landing gear is down locked. That's the answer to that one. All right, so that gives you an idea, and of course there are other questions that you can that you have available to you there that could potentially be on the test. So, but I wanted again just to kind of run through them, but through most of them, just to give you an idea of the questions that could be asked on the test. All right, so this concludes session 2 on the landing gear indicating and warning, and we'll go ahead and proceed to our next session. We are on now to session 3 of the landing gear topic, and this is on extension and retraction, which will include also free fall extension. So here we have, of course, you've got your regular extension and retraction, but you also have your free fall extension in the event that something's not functioning right with the normal extension of the landing gear. There's also 2 systems that we're going to be understanding more about, and that will be your electrical control system as well as the hydraulic system that pertain to this. We're going to go over the components for each of those categories. The hydraulic power is coming from the green hydraulic system. Okay, so that's where it's getting it from. And as far as controlling, the operation of the landing gear, the flight crew can operate that through a control lever. This is for the normal extension and retraction. There's a landing gear control lever that's located on the first officer's side of the center instrument panel. And then to the rear of that is the control handle for the free fall extension. So they're, close by there. But those are at least the control lever for the normal extension and retraction, and then you have a control handle that is for the free fall extension. As far as the electrical system, we're talking about an electrical control system, and there's 2 systems under the electrical control system. There's your LGCIU, you have 2 LGCIUs. And don't get too confused with the fact that one's called 1 and one's called 2. But, as far as their application and what they're going to be doing, I'll explain a little bit in just a little bit. So in each of these systems, okay, system 1 and system 2, where you have your LGCIU 1 or your LGCIU 2, okay, and again, I don't want to confuse, but you can actually have an LGCIU 1 in either system 1 or 2. Okay, so but at least you have the one control unit. And so in system 1, under the electrical, you have 16 proximity sensors. Same as system 2, you have 16 there. So there's a total of 32 proximity sensors that are part of being able to, have these inputs go and then into the control unit, and then obviously over to the system for hydraulic, to the actuating cylinders, etc., that operate the gear. So you also have, of course, electrical supplies for each of those. Okay, your system 1 and system 2, both of those connect to the control lever, and they're also connecting to the selector valve, the isolating safety valve, and then the door selector valve. So all those are connecting to that. And then, like I was mentioning earlier, you can have LGCIU 1, which is labeled that can be connected to system 1 or 2. And the same thing with the other one, it can be connected to either system 1 or 2, either way. So Let's go a little bit more into kind of the when we talk about the normal extension, you know, just to kind of give you a familiarity with what all we have here, okay? And that's going to be remember I mentioned the control lever. So this is a test question. When we're talking about the electrical control system, we have a control lever, not a control handle. So that's the landing gear control lever. And then, of course, you have your LGCIUs. Those are your control and interface units. And then the selector valves. Those are your for a gear. There's a gear and a door selector valve. Those are electro-hydraulic. And then you also have a safety valve as well, which is also electro-hydraulic. And then, of course, the sensors. Okay. And then, as far as any indication that we have on the display, okay, on the ECAM, we have green means good, right? Green just means the landing gear is extended and it's locked down, which is what we want. If it's not, then it's going to be in red. Okay, there's also a red light that shows up on the landing gear control lever itself, and that's going to come on if the gear is not locked down. Okay, of course, along with that, you're going to have your master, you know, caution lights that are going to come on. There's also going to be a chime that comes on as well. Now, what about the hydromechanical components in this system? Okay, remember I mentioned your hydraulic system, you have actuating cylinders. So here you have 3 landing gear and 3 door actuating cylinders. You also have bypass valves, so you can do some ground maintenance, so you're able to have that, you know, being able to function or operate the doors. So there's 3 bypass valves for the doors. There's up locks, your gear up locks. So your up locks are going to be for your doors and your gears. Okay, of course you also have your nose landing gear down lock release actuator, and you also have lock stay actuating cylinders. Okay. All right, so you know, also there's mechanical components. Okay, your mechanical components, so besides your electrical control system and what's there, and then your electro-hydraulic or, you know, hydraulic parts, you know, we also have mechanical components for the main landing gear systems. And this is going to be just your landing gear up lock, your down lock, and then you have your door up lock. Okay, those are installed. Your up lock is installed, okay, in the landing gear bay. Okay, so you have that. The parts for that, you got spring struts. Of course, that's the function of that is just to keep the up locks in the set position. And of course, also is decreasing the loads on the air and the structure of the aircraft, right? So there's a pin there that goes into the lock, making sure that it, you know, stays put. Okay, so that's what you have there. All right, so kind of a little bit on the LGCIUs. Okay, this is in the electrical control system. Is it's going to be receiving inputs, right? So just like anything else, you have sensors that are sending signals to a control unit of some sort. And in this case, we're talking about the LGCIUs. So that's receiving those position signals. And so it's using that to, of course, set the landing gear, door, and the selector valves to the right one. So what is it comparing? Because it's going to be comparing something. That GICU, okay, that GIU, excuse me, that landing gear control and interface unit is calculating the configuration that it needs, okay, with the for the door and gear configuration signals, and it's actually comparing that to what was the input from or the output, excuse me, from the landing gear control lever. So it's going to make sure, you know, is that jiving? Is that coming together? And then it's going to, based on that information, it's going to send the signals to the selector valves from there. So that's its primary. Okay, so for the control units and us understanding, you know, what's its primary function, its primary function is to compare two different things, signals coming from a control lever movement, and also just the necessary door and gear configuration signals. It's going to be kind of reconciling that so that it can send the signals to the selector valves. That's its primary. There are other things that the control and interface units do. A few things is monitor the control units to find failures, because it's going to automatically do a test. Okay, it's going to automatically do tests so that it can detect those failures. It also interfaces, that's why it's called a control and interface unit, is it's interfacing with the CFDS and the CWS. Okay, so obviously there has to be that signal communication between there and the display in the cockpit. All right, so and then as far as the proximity sensors, okay, since that's where it kind of starts and that's where that gets sent over to the control and interface unit. The proximity sensors are those indicators, right? And those are installed on the mechanical components, obviously, of each of the landing gear. And just so you know, it's a pair, so there's two sensors for each function there. And because you're going to have one sensor that's going to be sending signals through the system 1 and the other one through the system 2. Okay, remember we have two subsystems under the electrical control system, and they're called System 1 and System 2. Okay, so what is it going to do? These sensors are doing what? Okay, it's going to be sensing configuration of different things, such as, you know, the open position of the landing gear door, okay, the landing gear door up lock, as well as the down lock, the landing gear down lock and up lock. Okay, so that's what it's detecting there, position. The lever itself, okay, those were the proximity sensors. Now we're going to talk about the control lever in the normal extension and retraction system. Okay, so with this, it has two positions. You have up to retract the landing gear and down to extend it. Okay, those are the two positions. So when that control lever moves, what happens? Obviously, it's going to start, you know, sending signals to the LGCIUs. Okay, so that's what it's going to do. And it's just from a maintenance, so just so you know, there's a component in there. It's actually a solenoid, a bulk solenoid that actually stops the movement of the lever to the up position. That's what's causing it to stop there, and it does that when the plane's on the ground. Okay, when you have the CIUs that are sending a signal to release it, you know, to let that control lever move, okay, to the up position. So that's what it's doing there. There's an isolation safety valve. Okay, so you have that, your landing gear selector valve, and also your landing gear door selector valve. Okay, those are solenoid operated valves. It's part of the hydraulic system. And, you know, those are signals that are coming from the control units, okay, are controlling the operation of those valves. Remember I said earlier, once those proximity sensors are sending the signals to the control unit, then what? You know, the control unit's calculating. And after that, what's it doing? It's sending signals to the selector valves. Okay, also controls the operation of the selector valves, but then you also have a signal from the ADIRS, okay, your air data inertial reference system, and the control lever, and that's controlling the safety valve. Okay, and you'll see a picture there of what they look like. Basically, almost like other components, right? Just a rectangular box. Okay, so just to kind of go over a little bit more on the hydraulic system and what is it doing. Okay, we have actuators that are just going to move the mechanical parts, right? And that's pretty straightforward. You've been familiar with this, and systems are, you know, pretty much the same here. Of course, you have your hydraulic fluid that's going to be sent to the actuators through the valves, and that are going to move those components. Okay, so the valves, like I mentioned before, your isolation safety valve. You also have a selector valve and manifold assembly. That's together, okay, and that's including the landing gear door selector valve and the landing gear selector valve. So selector valve and door selector valve. Okay, now remember the sequence of operations, you know, and everything being done is being controlled by the LGCIU. Okay, as far as the isolation safety valve, it's just so you know, it's a two-position valve, and it's going to, you know, isolate the landing gear hydraulic supply. from the green hydraulic system. So that's what it's doing. It's making sure that it's getting it from the green hydraulic system. And also, you know, it's called safety valve, because what it's doing is it's stopping the extension of the landing gear if the aircraft is moving, you know, more than 264 kT to prevent that damage. So at a certain point, it's stopping as a safety. Okay, so what is the selector valve and manifold assembly doing? It's controlling that flow of the hydraulic fluid. Okay, you have different lines that it's going through, and it's going to control the flow of that going to different lines. So you got your door and your extend and retract lines. Okay, so that's where it's going, but it's controlling that flow to there. Okay, and so here, just wanted to share this one thing. So if you're going to open the landing gear doors, okay, so to open them, this is for access when you're on the plane's on the ground. And remember, each of the landing gear bay has a mechanically operated bypass valve. Okay, remember I said that bypass valves, they're right there in the landing gear bay. So these valves isolate the door actuator from the door's closed pressure line. Okay, because you have an open and closed lines. And then it's hydraulically connected to two sides of the actuator together. And that's just being able, it's there so it won't allow the doors to move if the system is actually pressurized. Okay, so to let the landing gear extend, this is on free fall, it's just completely mechanical, so purely mechanical. You got rods and, you know, stuff. So again, simple mechanics on the free fall extension system. So to do this, there's these cutout and vent valves that are there, and those are there to prevent the hydraulic fluid lock in the actuators. So that just so you know, those components are part of the free fall extension system. And you also have safety valves and restrictor valves. The safety valves, of course, are keeping the hydraulic fluid upstream of the safety valve. You want to make sure that there's no problems with when you have leaks. Okay. Your restrictor valves are installed in the selector valve and manifold assembly, and that's part of controlling the rate of flow. Okay, that's going through the extend lines. So that's part of that. I mentioned the restrictor valves. Remember, I said the purpose of the selector valve and manifold assembly is to control the flow, and part of that, you know, that assembly is the restrictor valves, or the restrictor valves. And diagram kind of shows you an orientation with, you know, how they're related to one another there. Okay. Okay, I already mentioned the mechanical components, so I'm not going to mention that again, but just, you know, there's only the up lock we got the up lock and down lock of the landing gear, and also you have the door up lock. And those are installed in the landing gear bay. Okay. Okay, so kind of just a little bit on the handle. It's just a mechanical, you know, thing. I mean, you have on the talking about free fall extension system, you have that control handle. Okay, but that's to differentiate from control lever, just so we're clear, because that's a test question. But you know, they are near each other. It's the rear. It's in the rear of the center pedestal, and it's operated, you know, and mechanically controlled. And so what happens is this mechanical system is also causing the cutout valve. And remember, I mentioned the cutout valves and the vent valves, and it's actually allowing that to move, you know, in a certain order. Okay. And just kind of an order of things with the free fall extension, because remember, it's using gravity to do it, to bring it down, you know, bring the landing gear down. So with here, when you have the handle assembly, okay, on that center pedestal, and when you move it, okay, it's going to be moving. It's just like when I talk about, remember, if you're familiar with the Boeing 737 original series, I mean, even the 737 Next Gen has some partial mechanical systems in there with the links, okay, underneath the floor of the cockpit, right? But so here's this kind of similar thing. You've got cables and you have mechanical links. The sequence is that, number one, the cutout valve operates. Okay, and pay attention to this one because this is a test question. that you understand the order of the operation of the free fall extension. So number one, the cutout valve operates. Okay, so when that operates, what happens? It means the pressure supply line closes, okay, and the landing gear hydraulic supply system is connected to the return. And number two, you have your nose landing gear, your main landing gear vent valves, okay, so main and nose, that are open, okay, so the hydraulic fluid, and you have hydraulic fluid from the door actuator closed chamber and from the retractions chamber are going, that fluid is going to the reservoir. Okay, number three, you're going to have, the next step is the landing gear door uplocks release. Of course, then the door's open. Okay, and then for your main landing gear, nose landing gear, those uplocks release. Okay, the main landing gear, nose landing gear extends. And then the last is the check valve. Okay, the check valve operates, then the supply of hydraulic fluid is increased. Because you want to, the problem with hydraulic fluid in certain areas within the hydraulic system is cavitation. That's one of the threats. So you want to make sure, of course you have contaminants, if you understand about the threats to hydraulic fluid, which affects obviously the components within the system. One of the problems that we have is the cavitation issue. So the check valve operates, then we have a supply of hydraulic fluid to the extension chambers, and it's going to make sure that that hydraulic fluid is increased in those areas so that you don't have that cavitation issue. Okay, so kind of gives you a little bit just a chain of events with that operation on free fall. Okay, all right, so not much on normal. I mean, we just talked about normal and extension. Okay, that's normal, retraction and extension system, and then of course you have your free fall, in case we have a problem with the normal operation. This is the backup to ensure that the landing gear is there for landing. So that's pretty much it. Okay, so we're going to go ahead and go into some knowledge checks. All right, we are going to cover some knowledge checks for session 3, which is on extension and retraction. And some of these questions you're going to see them on the test. So let's go ahead and just kind of go over some of these. How many LGCIUs are there in the landing gear electrical control system? Are there 2 or 3? Okay, it's 2, right? Okay, question 2. The blue hydraulic system supplies the hydraulic power for the landing gear system. Is that true or false? It's false, right? It's actually the green system. All right, number 3. There are 32 proximity sensors in each subsystem of the electrical control system. Is that true or false? Okay, the answer is false. I said there were 32 total, but for each subsystem, there's 16. Okay, number 4. Name a few primary hydromechanical components in the normal extension and retraction system. Here's your choice. 1, is it control handle and 3 landing gear actuating cylinders, or 3 gear uplocks and 3 door bypass valves? Okay, it's the latter. Right. All right. Number 5. The landing gear downlock indication lights show in what color? Okay, when the landing gear is extended and locked down. Is it green or red? Okay, it's green. Right. Okay. Question 6. The landing gear control lever is a component of the electrical control system. Is that true or false? Okay, it's true. Okay, what is the primary function of the LGCIUs? Okay, option 1. To calculate and compare configuration signals between necessary door and gear and that requested by the landing gear control lever. Or option 2, to supply landing gear and door position and system configuration data to other systems? Okay, it's the former. Okay, first thing. All right, question 8. Regarding proximity sensors, how many are there installed per function? Is it 1 or 2? Okay, it's 2. Remember I said there was like pairs. Okay, number 9. The hydraulic system of the landing gear system has which components? Proximity sensors or actuators? Okay, it's actuators, right? Okay, number 10. What controls the hydraulic fluid? Okay, option 1, the selector valve and manifold assembly, or the isolation valve and LGCIU. Okay, it's the former. All right, number 11, the free fall extension system is hydromechanical, or is it mechanical? Okay, it's mechanical. Remember I said it was pure, the free fall is purely mechanical. Question 12, what prevents a hydraulic fluid lock in the actuators when extending the free fall system? Is it option 1, mechanically operated cutout and vent valves, or mechanically operated safety and restrictor valves? All right, it's the former. Okay, the first choice. Okay, question number 13, where are the door bypass valves located? Is it on the landing gear doors or in the landing gear bay? Okay, so landing gear bay. Question 14, in the hydraulic system of the normal extension and retraction. Okay, let's go to actually 14. 14 is the landing gear door selector valve and landing gear selector valve operate in conjunction with one another. Is that true or false? Okay, I'll do it again. The landing gear door selector valve and landing gear selector valve operate in conjunction with one another. Is that true or false? Okay, it's false. They actually operate independently. Okay, question 15. How do you open the landing gear doors from the ground? Okay, option A, operate the landing gear isolation valves or operate the bypass valves. Okay, it's the latter. Okay, number 16. What is the function of the isolation safety valve? Is it option 1, to stop the landing gear from extending when the aircraft is more than 264 kT, or to isolate the landing gear door actuator from the door's closed pressure line? Okay, it's the first choice. All right. Okay, so it kind of gives you an idea of some of the test questions that you may see. So, of course, if you have any questions, you can email us and we'll be gladly to answer those questions. All right, we're going to go ahead and move on to our next session. We are now on to session 4, which is the main landing gear. And we're also going to go over the main landing gear doors as well. So let's go and just go over I just want to show you the diagram to just look at that and just get some orientation on the components and what makes up the main landing gear. You've got torque links, of course, the shock absorber. You've got your side stay assembly, retraction actuator, and of course you have the dressings. So, and you can see the main landing gear there. Okay, so those are your main parts to the main landing gear. Okay, and so just a little bit on the different ones. You've got, for example, your main landing gear leg, and you got torque links, the retraction actuator. Okay, that just connects the wing structure and the landing gear forward hinge point. Okay, that's what the cylinder does, is connect those two. And the inflation valve, just to mention that, is there. The valves are there to fill the shock absorber with the hydraulic fluid and also with the nitrogen. Okay, the dressings, those are between the main fitting and the sliding tube. Between those you have a slave link, and you have electrical cables and hydraulic pipes. that it holds to make sure it doesn't catch on the wheels. You also have a spare seal activating valve that's on the main fitting, and that operates if there's a hydraulic leak through the land seals. So you have that there as well. And just in the other diagram, you can see the different parts. You've got the drag stay, the cross tube, shock absorber with the inflation valve I just mentioned, and the spare seal activating valve. And then you also have a damper, the torque link damper. Okay, you got lugs, your up lock pin, you can see that there, your lock stay, side stay. Okay, all right, so kind of to start with the main gear leg, you've got 2 leg assemblies. Of course, you've got, you know, the side stay assembly is preventing that sideways movement of the main landing gear. The main landing gear has 2 primary components. You got that main fitting that I mentioned earlier and the sliding tube. Okay, so those are the 2 parts to the leg, is the main fitting and the sliding tube. And each of those has a one-piece assembly. It also contains the shock absorber, so you have that. You also have the axle, that's part of the sliding tube. And then, you know, you can also have a wheel speed tachometer with that. There's a drag stay. That drag stays between the main fitting and the forward end of the hollow tube that holds the retraction actuator. Okay, you can see that referred to the diagram again. Okay, and you also have the barrel of the main fitting is a cylinder. It's closed at the top, and that makes up the outer part of the shock absorber. Okay, the main fitting, okay, that barrel I just mentioned is part of the main fitting. Same with the drag stay, the sliding tube, or excuse me, the cross tube, and you've got the lugs. Okay. Sliding tube is just made of obviously a high tensile steel for what it does, because it moves a lot. It needs to be flexible in the middle, so moves in the main fitting is, you know, that's there, and the primary component, you know, is a primary component of the shock absorber, that sliding tube is. The axle and the sliding tube are a one-piece component. Okay, all right, and then you also have a jacking dome that's at the bottom of the cylinder. Okay, actually, on that diagram. Okay, now the shock absorber, just a little description on that. The shock absorber has 4 chambers. You have a first stage and second stage gas chamber. Your first stage is going to hold low pressure gas pressure, and the second stage is going to be high pressure. And then you also have a compression chamber and a recoil chamber. Okay, and primary control of the recoil here is going to be fluid flow. Okay, that's going to be controlling that recoil. Okay, you're going to have the fluid flow in the from the recoil chamber into the gas chamber, or the other way around. There's also a damping tube which has the first stage orifice, and that attaches to the head of the second stage cylinder. You also have, of course, as it goes, you know, that movement of the damping tube, you know, moves, then it's going to be decreasing the fluid flow in the first stage damping. Okay, so it's basically increasing the dampening effect, or damping effect. And then the second stage, you have a floating piston, and what that's doing, it's separating the hydraulic fluid of the compression chamber from the gas of the second stage chamber. And there's a blowout view you can see showing the recoil plate valves, and you got the damping tube in the middle. You can see the first stage orifice. Okay. Then you also have that spare seal activating valve. It's basically here set when it isolates the bottom gland seals in case there's a leak. So it's just basically protecting that. So activating valves on the barrel of the main fitting. Okay, and so it operates when you remove the cap screw and you turn that valve stem. Okay, Where is the spare seal activating valve located? It's on the aft side of the main landing gear shock strut. Okay, so that's its location. And you can see a blowout of this one here in the view, showing the cap screw, the valve stem. You also have a wiper ring there and a cylinder. You got your gland seals. Okay, of course your main fitting there. Okay, so part of all this, you also have a torque link damper. The damper has its own reservoir, its hydraulic reservoir, so just something to be aware of. Check valves at the bottom. You can see that in the diagram. Check valves at the bottom. You have the damper body with the reservoir at the top, okay, of the damper body. And you've also got the bleed screw and the bleed plug at the top. Okay, and also as indications on the actual reservoir, you've got the words full and refill that are there, so you can see it, know whether or not it's needs to be refilled. Okay, all right, so now what about the side stay assembly? You have different components that make up the side stay assembly. That would be your lock stay actuator, lock springs, your basic side stay. You've got hydraulic hoses, so they all connect, and you can see it from the picture just how they relate to one another. You get your lock stay, of course your actuator, lock stay actuator is there, and then you have also the wing structure, that joint that's there, upper and the lower side stay, and of course your springs. All right, so for the main gear doors, you have 3. Okay, you have and you have both where they're hydraulically operated as well as mechanically operated. So you have the main door being hydraulically operated. You have the fixed fairing door, and you have a mechanically operated hinged fairing door. So you got a hinged fairing and a fixed fairing door on the leg. So when the main landing gear retracts, all the doors are going to close. Okay, when it extends, then the hydraulically operated doors close and the mechanically operated doors are going to stay open. So just to differentiate what's happening here, if you see the picture, you can see where the doors, that are hydraulically operated are located. They're, as far as when you look at the nose landing gear area and the main landing gear, they're going to be in the forward part as far as your hydraulically operated doors, and then the gear operated ones are going to be behind that, or mechanically operated. That's the same thing. If you see gear operated, obviously mechanically operated. So that's what you have there, is differentiating, when that happens. So operation, main landing gear extends, then those hydraulically operated doors are going to close, and then those mechanically operated doors are going to stay open. Okay. Okay, then you have a bypass valve if you need to do ground maintenance, okay, plane on ground. Then you have that door opening mechanism that lets the hydraulically operated doors open on the ground. Okay, so you can get into the bay. Okay, and then if you have where the main landing gear doors close, then they keep the contour of the outer skin of the aircraft, right? And they're protecting, obviously, the equipment in there. All right, and then the main door itself has the proximity switches, access steps. You have 2 door ramps and also an actuating cylinder. Okay, you can see it's kind of a rudimentary picture, but still give you an idea. Okay, on the picture. Okay, so you got hinge fairing and fixed fairing. Okay, I mentioned that earlier. The hinge fairing is installed on a hinge on the lower wing surface. The fixed fairing is attached to the outboard side of the landing gear main fitting. And the fixed fairing is attached by 2 types of attachment assemblies. You have one that has 2 adjustable studs, and then you have the 3 adjustable rod ends. Okay, one that's installed in the front of the main fitting, and then 2 are installed in the rear part. Okay, what about the ground door? Okay, so there's that, and then you have a ground door, the opening mechanism for the main gear ground door. We'll get into nose landing gear in a little bit, and in the next session. But here is the main gear ground door. So you have a bypass valve. You have there's a handle, so you have a handle, bypass valve, and you have the release mechanism in the up block. Okay, so you have a handle. You've got cable that attaches to the apex of the fork, and then you have a release plunger at the hand grip. Okay, that releases that mechanism so that you can open it. So the handle's connecting, okay, the push-pull cable, to the lace shaft, and then on the door bypass valve on the outboard side of the bay. And of course, do make sure that you keep things clear, because obviously when the doors are opening, you don't want to have something in the way of it, because you can cause damage obviously to the objects, to the aircraft, or to people. Okay. And it's just the door bypass valve, just a little on that closes the hydraulic supply pressure. Okay, and it connects each side of the door actuating cylinder together. Okay. And about the operations, we're talking about the ground. Again, just be safe. When you're have done things for a long time, some people get complacent and just kind of take it like, oh, I can do this in my sleep. But I'm just giving you a little note about, I guess, awareness right now about safety. Always be safe, and pay attention to things around you. Okay, so with here in operating the ground, door, it's cable. You have a cable which moves a lever on the bypass valve. It's going to move through 90 degrees. Okay, so the initial movement on that handle is going to cause that valve to isolate the supply of hydraulic power. So it's going to do that from the hydraulic, from the door actuating cylinder, and then it's going to connect those two chambers. Remember I mentioned that earlier. Okay. Of course, you've got to have a pressurized hydraulic system to make that happen. So if you're on ground, you need to make sure that green hydraulic system is pressurized before you do ground door opening. Move the handle. Okay. It shows you the pictures. It shows you the cable as well. Gives you can just see it from the diagram. Open position, etc. on there. Okay, so kind of really not much to that. Again, just understand all the safety when you're doing stuff on the ground as far as opening mechanisms, and then just kind of again familiar with the different components like your side stay assembly and your spare seal actuating valve, bypass valves, your torque link damper, obviously the shock absorber, so things like that. Okay. All right, so this concludes session 4, and we're going to go ahead and do just a handful of knowledge checks, and then we'll move on to our next session. Okay, so these are knowledge checks, not comprehensive, but some of the knowledge checks that you may come across on the test for session 4 on main landing gear. Okay, question 20. What is the inflation valve used for? Okay, here are the two choices, and you can follow along with the handout. Number 1, to fill the shock absorber with hydraulic fluid, or the next option is to fill the sliding tube with hydraulic fluid. Okay, it's A, or the first one. Okay, to fill the shock absorber with hydraulic fluid. Okay, question 21. What connects the main landing gear leg main fitting and the wing structure? Is it the retraction actuating cylinder or a 2-piece side stay assembly? Okay, so 2-piece side stay assembly. Question 22. The main fittings of the landing gear leg has which parts? Okay, cross tube, main barrel, lugs, and drag stay, or brake fitting, cross tube, and axle. Okay, it's the first choice. Okay, question number 23. The axle is part of the sliding tube. Is that true or false? It's true. All right, question 24. How many chambers does the shock absorber have? Is it 3 or 4? Okay, 4. Okay, question 25. Where is the first stage orifice of the shock absorber? Is it the damping tube or in the second stage cylinder? Okay, it's the first one, damping tube. Question 26, the torque link damper has its own hydraulic reservoir. Is that true or false? Okay, it's true, right? Okay, question 27, where is the spare seal activating valve located? Is it on the axle or on the aft side of the main landing gear shock strut? Okay, you're right. It's the letter, right, on the aft side of the main landing gear shock strut. Okay. All right, this concludes the knowledge checks, at least, again, giving you an idea with some of the potential test questions for session 4. We'll go ahead and proceed to our next session. All right, we are now on to session 5. This is the nose landing gear. And similarly from, like when we talked about main landing gear, we have some components with the nose landing gear that are similar, but there's some other things here too. So I just want to give you just some of the terms that we have. The safety pin, you have an electrical box, obviously the shock absorber, so we do have that. Your steering actuating cylinder, okay, towing fitting. We got torque link assembly. We also have the steering servo control. Okay, and we have the feedback sensors, the trunnion, rotating joint. Okay, your actuating cylinder, up block roller, the force stay. Okay, obviously the wheel, and you got the axle there. Okay, so actually let's just kind of go over, obviously the nose gear, just to give a little description on it. It's a direct acting type that with the integral shock absorber. That gear retracts forward into the fuselage. Okay, then you have your sliding tube assembly, the shock strut, got a rotating tube. Okay, there's the lock stay assembly. Okay. There's also the nose gear actuating cylinder. The cylinder here is a double acting type of actuating cylinder with a spherical bearing at each end that operates that nose gear. Okay, the radio type, you have tires. The tires that are installed here are the heavyweight wheel tire assembly. So just giving you a little description on that. And it depends on the air. I mean, we're talking about the 319 or 320. There may be slight differences on the wheel tire assembly, so just be aware of that. Do read the AMM and make sure that specifically, you're looking and making sure you have the right tires for the right model. Okay. Again, just kind of referencing just keep referring to the diagram as we go along here. Okay, we do have the shock absorber. This is, we had the shock absorber with main landing gear, obviously, that had 4 chambers. This one's a single chamber type that has a separator piston and it's double acting, which a lot of these are either the piston or the cylinder. The shock absorber, okay, same thing with it's a typical design to have, or setup is that you have hydraulic fluid and nitrogen there that can be serviced through basically one valve at the upper part of the leg itself. Okay, there's also a placard that's bonded to the leg that shows the filling curves. Okay, that's whether the shock absorber is at the correct pressure. okay, for the length of the sliding rod. The shock absorber itself in this setup is 2 centering cams. You have one that's part of the plunger tube, and then you have another one that's part of the sliding tube. Okay, so there's a cam for each of those. And when you have the shock absorber that's fully extended, then the pressure of the nitrogen is going to cause the cams to engage. Okay, the wheels then, you know, are going to automatically return to the center position. Okay, and you can see the view of the shock absorber for the nose landing gear. You see the actuating cylinder there, and you know, upper the centering cam. You see your plunger and your sliding tube. Okay, there's that. And then you've got the piston, obviously the bearing, upper and lower cam, etc. And the nose gear doors. The doors, there's 2 forward and 2 aft. You've got, you know, one that's mechanically driven. The other one's the hydraulic, driven by or operated by hydraulics. So you got an actuating cylinder there. There's the 2 main doors that are symmetrical in relation to the center line of the craft. Okay. And as far as the doors, there's 3 points that it hangs, you know, is attached to the structure. Okay. And then the 2 doors there are connected mechanically to the aircraft by the linkage. Of course, you have the 2 rods that are connected to the same bell crank that's installed at the roof of the landing gear well. Okay, that's how that's all connected there. Okay, so kind of give you an idea of what they look like. The picture shows that what the forward doors look like compared to the aft doors. Okay, on the Airbus, and your aft and forward doors, and your leg door. Okay, just looking at the configuration there of each of those doors. Okay, and always pay attention. Okay, I'm just saying, I mean, we're, you know, always about safety, and we could do a whole, you know, we'll be doing more of that with safety shows and etc. But safety, just be aware, again, we have moving parts here, and just pay attention also to what the placards say on the legs, on the leg door, before you start, you know, making things happen there. Okay, so you have that, and you also, when we talk about the, yeah, a little bit more on the leg door, there's 2 rollers to that. The main doors are going to come against the rollers when the door closes, so in opening, always be careful there. But again, the main doors come against those rollers so that it can close after the retraction of the gear. Okay. So, takeaway here. Because remember, compared to main landing gear, we had 4 chambers for the shock absorber. In this particular case, we only have what? A single chamber. Okay, so that's one big difference there. And again, the drag strut and lock stay assemblies that you have, you've got that drag strut assembly with the lock stay locks. It locks the gear leg in the extended position. That's what that is there for. Okay, and you have the forestay and the tubular arm that are connected by a joint. Okay, universal joint there. Okay, it kind of covers, and this is just an overview. I mean, the components are pretty simple. You get, you know, what I mentioned before, and you can see it on the diagram. But you know, with the safety, you know, safety pin, your actuating cylinders, etc. Okay, so if you were asked on the test, you know, what components you know, make up the nose gear assembly, then we're going to say we have an actuating cylinder, right? We have a drag strut assembly. We have a wheel steering assembly, and there's a leg assembly. Okay, so 3 assemblies and an actuating cylinder. basically. As far as the doors, you have 2 main door assemblies, and then you have 2 aft door assemblies and 1 leg door assembly. Okay. And they also have the proximity sensors that are on the nose landing gear and on the nose landing gear doors. Okay, remember, all the proximity sensors are going to send signals to the control interface unit. Okay, so that's where that would all be going. Okay, so that's a test question. So let's just go over a few things. So what comprises that? I just mentioned those different components that make up the nose gear assembly. Okay, so, and we know proximity sensors are there. All right, and how many chambers does the shock absorber for the nose landing gear have? Does it have 1 or 2? Okay, it has 1, right? Okay, and then nose gear uplock, I didn't mention it before, but the gear lock uplock assembly, that's going to hold the gear in the retracted position, right? And you're going to have a roller there installed on the upper hinge pin of that drag strut joint to make that happen. Okay, so pretty straightforward. All right, so that concludes all on the nose gear and its doors, and we're going to go ahead and move on to our next session. All right, we are on to our last session. This is session 6 on wheels and brakes. So we'll go over the brakes system on the Airbus A320. So just kind of give you an overview. We have actually, we want to know what our supply is for the brake system. And so here it's, I mentioned earlier about the landing gear hydraulic supply is coming from the green hydraulic system. Here we're talking about wheels and brakes. It's coming from 2 different systems. We have green hydraulic system that's supplying 1 set, and then we have the yellow hydraulic system that's supplying the other set. That also gets help from the pressure accumulator on the yellow side. So just to start, we've got that. So we're going to be talking about the wheels, the brakes, the tires, anti-skid system, the parking brake as well. So we got that, and just kind of understand different braking modes and that kind of thing. Okay, so important that anything have brakes, right? We're talking about aircraft, so very important that they be maintained. So here on the main gear wheels, they're carbon brakes. There's 2 sets that operate independently. The green hydraulic system is supplying again for 1 set, the yellow for the other, and they have automatic adjusters to them, 2 wear pin indicators and a temperature sensor. Also, the way they can be put into motion is the auto brake system or by the pedals. Either way. There's an anti-skid system that's going to help with the braking efficiency. Okay, it's just going to help that. And there's 4 different braking modes that can be. I mentioned parking brake system. So you got normal braking, okay, just normal brakes. And then the alternate braking with the anti-skid, and then you also have alternate braking without the anti-skid, and then you have the parking brake. And depending on what mode you're in, it just, what's available depends on the hydraulic system that's being used, okay, as well as the position of the anti-skid and the nose wheel switch and the park brake control switch. So it kind of depends on what's going on there. All right, so in normal braking, let's just start with that, and then we'll go to alternate and continue on with parking. But this here, of course, is coming first from the green hydraulic system, so that's where it's coming from. And then also it's in normal, or is normal, when the A skid and nose wheel control switch is in the on position, and also when the park brake control switch is in the off. So these are all conditions that need to be. Okay, when you have green high pressure available, and then you have the anti-skid and nose wheel control switch in the on position, and then the park brake is in the off position. Or you have the park brake control in the on position and the parking brake pressure really applied is less than 507 psi. So that's another condition of that. And again, like I mentioned before, the two ways you can control control the brake system is through the pedals, or automatically on the ground by the auto brake system, or in flight, either way. Because in flight, it's when the landing gear normal control lever is put in the up position. Okay, remember I mentioned that control lever. So when that's in the up position, then you're going to have that control. All right. And of course, the pedals are mechanically operated. Like you've got rods and bell cranks that are mechanically linking to the pedal controls. Okay, so left pedals control one of the input levers of the brake pedal transmitter unit, and then the right pedals control the other lever. And you can see a schematic that shows you, what's happening with that. Okay, so functions here, we're talking about the control unit. Okay, we had the LG CIU for the landing gear, and now we have one that we're talking about for the braking steering. So with here, it is a control unit, the BSCU, that I'm going to refer to. So braking steering control unit, BSCU. Here, what does it do? Well, it's going to be doing different things, right? It's going to be doing similarly to what the LG CIU was doing. Is basically it monitors. Okay, it's going to check for failures, and it's going to record that. It's going to locate those failures during the maintenance operations from the CFDS. Also, there's steering control, nose wheel steering control through the hydraulic block, and also the actuating cylinder. Okay. You also have braking regulation through the check of the speed of each braked wheel, and braking control through the servo valves and also through the pressure transducers. Okay, and then if for some reason there's a disagreement between the control and the monitoring channels, then the system is disconnected. It cancels it. Okay, and the system is just going to be in standby. Okay, so when we talk about BSCU, we're talking about an electronic unit, so we're talking about avionics compartment. So if you needed to access that area, if this is going to be installed in Rack 90 VU, okay, and the way you're going to access is it through door 811 on that. And it's kind of a rudimentary blowout of that. Okay, so now that was the control unit. Now there's a brake pedal transmitter unit. And so here it's taking, the mechanical input from the left and right pedals into voltages. So remember I said about the auto brake system, and then, we have also the option of pedals. If the pedals are engaged, then that's rods and cranks, right? Bell cranks. So you've got that mechanical input from those pedals that's going into and being transformed into the electrical voltages. Okay, so that's all the signals that are going to be going into the brake steering control unit. Okay, and just so you know where that transmitter unit is located, this one is actually under the floor on the first officer's side. Okay, there's also a selector valve. The selector valve is a three-way type. And what is it doing? Okay, it's isolating the normal braking system, and it's going to do that when the pedals are released, or the normal braking's not selected, or the solenoid is just de-energized. Okay, so for the selector valve, that one is located in the hydraulics compartment that you can access through the left and right main landing gear wheel well. Okay, you see from the picture, it shows you the selector valve there. Of course, you have a filter, that's a basic filter. Okay, there's your input lever. Okay, so that's with the pedals, and then let's say you have an automatic selector. With this, it's just automatically supplying, or has automatically supplying the braking, and this is going to be doing it during the normal or the alternate braking systems. It just depends on what hydraulic systems available at the time. Okay, so in here, when the pedals are released, then the yellow system positions that slide valve in the automatic selector. So you can have that for the alternate braking. And just so you know, for the location on the automatic selector, that's in the right wheel well aft end. Okay, then you have servo valves. There are 4 servo valves. There's one for each brake. Okay, those are in the manifold, which are in the shock struts on the main landing gear shock struts. Okay, you got safety valves as well. Those are there. The valves, those are put between the brake servo valve and the brake itself. So what is it doing? The safety valve. Okay, we want to make sure it stops the flow in case there's a leakage, right? Same as what we were talking about in the landing gear. Well, in the brake system, we have similar, same function here with the safety valve. And here, the key thing is, of course, follow the AMM, but this is made to operate only if the flow is more than a certain amount. In this case, more than or equal to 4 liters. Okay. And just to get an orientation of the breakdown of the safety valve, you can see kind of an exploded view here. Okay, so that was with normal braking. And then remember I mentioned about alternate braking. It's associated with a yellow high pressure. So here, alternate braking you can have with or without anti-skid. So here is going to be we're going to talk about with anti-skid. And so you can get into this mode automatically if the green pressure is just flat out unsurfaceable. It's not available for whatever reason. So it's not available. Or there's a certain failure that occurs on the normal system. If anything's detected there, it's just going to automatically switch to the yellow high pressure for that braking. Okay, and there's here you got pressure that you can operate since you can control the alternate brakes also with the pedals. So you have that option. And the anti-skid, as far as regulating that, that's used for the normal system, but they're also used for the anti-skid regulations. So that which you use in normal is going to be the same that you're using in the anti-skid regulation. Okay, and then you have also the pedal artificial feel. This is a hydromechanical system that's going to transmit the control inputs at the pedals. Okay, now this mechanical system is between the master cylinders and the distribution dual valve. Okay, so we also have a reservoir for the brake control, and we'll talk about the master cylinders a little bit. Okay, so we have the reservoir that's part of this, and that's going to be supplying the master cylinders. So with master cylinders, there's 2 of them, one for each side, and they're controlling the distribution dual valve of the alternate brake system. Okay, it's giving also artificial feel at the pedals. Okay, that's what those master cylinders do. Alright, and so master cylinders, where are they located? These are going to be access door 811, okay, like earlier in the avionics compartment, which is what that is. Okay, so a little bit more on the distribution dual valve. You've got pressure reducing valves as part of that, and also a main gear. So that cylinder's operating each of these distribution valves. Okay, and that's installed in the hydraulics compartment on the right wheel well aft end. All right, you also have a shuttle valve as part of that. That's also located in the right wheel well aft side. Okay, and your pressure transmitters, those are going to measure out the pressure, okay, at the outlet of the dual shuttle valve that I just mentioned. Okay, you do have servo valves. There's 2 of them, and besides that, and there's an alternate brake manifold that's where those servo valves are. And then so you have 2 servo valves. You have a filter. And then you have 2 safety valves that are part of the filter. And the picture just shows you what the servo valve looks like. Okay, so that was a little bit more on the with anti-skid. This is the alternate braking without the anti-skid. So if you're going to look at the alternate off, okay, that's without anti-skid, it's different from the other ones. The anti-skid regulation can be disconnected. Okay, you can disconnect this hydraulically. Okay, and that's if the brake yellow pressure accumulator only supplies the brakes. Okay, if that's the only thing it's supplying, or electrically. Okay, so as far as the artificial characteristics, okay, those are the same in the case, without anti-skid. So that's that. And then remember, if the accumulator only is supplying the brakes, the maximum pressure supplied to the brakes is about 145 psi higher than in the alternate, with anti-skid. Okay. All right. So let's kind of talk a little bit about the accumulator. I mentioned accumulators before, and kind of just generic hydraulic system, but this is just a I say typical, but that's the bladder type. There are different kinds of accumulators if you studied it at all or seen them, but the accumulator is the bladder type. Yeah, of course you have the filling of some of that with nitrogen, and this is strictly used for braking. Okay, so this one is either going to be pressurized by the yellow hydraulic system or with an electrical pump. Okay, and check valves are there to isolate those supply lines. So here the brake yellow pressure accumulator supplies the system. The brake does that, supplies a system that a thermal pressure relief valve protects. Okay, you have the relief valve. It's going to limit that pressure to 3,436 psi. By the way, that number should maybe ring a bell for you, but 3,436 psi, because I had mentioned that before. But anyway, so pressure relief valve limits the pressure to 3,436 psi. Okay, so if there's some reason the temperature goes and you have an expansion that happens, then you can, if for some reason, you can actually also use the manual pressure release. Accumulator is located in the right wheel well aft end, just so you know on that. Okay, so a little on parking. This is emergency braking. This is the ultimate. Of course, you want to have pilots prefer to have a normal braking system, but here you got braking or ultimate emergency braking. Here the control handle is located aft on the center pedestal. Okay, and the park brake control switch, when you have that in the on, it's going to deactivate the other modes, and it's going to supply the brakes with that yellow high pressure in doing that. So what happens when the parking brake control switch is in on position? Okay, so this is an emergency. The pilot needs to put it in the parking brake position. So in on, So that what's going to happen is going to automatically do something. It has to immediately do the wheel lock up. And so this is what should only be used in an emergency stopping measure. It absolutely has to be used. So that's what, because you don't want to, there's a lot of, obviously with physics behind all that, it has to be a last resort. But internal passages inside the parking brake electrical control valve is going to limit the pressure that's supplied to the brakes. It's going to limit it to 2100 psi when that brake is set. Okay, so that's the max pressure. Okay, and just so you know, as far as holding those brakes, that's that accumulator that comes into play. The accumulator has enough capacity, in there to hold the brakes for 12 hours. Okay, minimum 12 hours. Okay, and there's also a warning light that comes on the ECAM. So it's a 2 config. Okay, a 2 config warning light. Okay, and that's to remind the crew, to release the parking brake when the engine's at full throttle. So when that's important, an important warning light that would come on the ECAM. Okay. And just kind of a little side note, it's not probably a really big deal, but the in-wind speed shouldn't go greater than 75% with the parking brake, on. Okay, and you can see kind of the way things can run with the, as far as run, the kind of the process there with the emergency braking. Okay, so yeah, so with the position, as far as the park brake switch, it's a 2 position. Okay, off and on. There's no more than that. Okay. You also have an operated valve. It's the parking brake operated valve, and that is installed between the brake automatic selector and the dual valve of the alternate brake distribution. So what is this doing? Okay, it's going to shut off supply to the brake system, and again, in order to prevent leakage to the dual valve. That's what that function is. Okay, and just a little bit on the anti-skid. Remember I mentioned you can have it in the normal brake system, or you can have it in the alternate brake system as well. And then of course the regulation of it is coming from the BSCU, right? So it makes sense. Okay. As far as the location on the instrument panel, you're going to find that A skid and nose wheel. Remember I said that before, it's A/skid and nose wheel. That phrase right there is a control switch, and that's on the center instrument panel. Okay, and as far as display, what you're going to see on the wheel page, it's going to have normal alt braking mode. Okay, and the selected deceleration. And then any warnings are going to be there also on the upper display. Okay, you also have a tachometer. So you have a tachometer as well for rotation of the wheel. Okay, there's also, you also have the nose wheel steering. Nose wheel steering is electrically controlled through the dual channel brake and steering control unit. Okay, what I mentioned earlier, BSCU, is controlling things. So that is processing both the pilot or autopilot commands, so it can control the nose wheel steering. Okay, and just kind of be aware. I know I mentioned some things are mechanical and some are not. There's no mechanical connection between the nose wheel and the controls available for steering. So, it's like, unlike some of the things we've seen before where we have, like the rudder pedals, we have rods and bell cranks, right? Okay, so with nose wheel steering, of course, very important to have steering. The way they're going to do it from the cockpit, let's say they're taxiing, and of course they're at low speed when they're taxiing, then it's going to be through the action of a hand wheel. There's two. There's one for the captain, one for the first officer. If for some reason they both, decide they're gonna, take control, then the orders that the hand wheels give are algebraically added. Okay, it's going to be a combination of the inputs from first officer and from captains on those hand wheels. So there's a max though. There's a max travel, maximum travel of the wheels is plus or minus 74 degrees. Okay, so just kind of note that. You also have let's say we have a takeoff or landing. So we have low speed if we're taxiing, but if we're taking off or landing, essentially we're at higher speeds. Then what? We have a steering angle that's limited as a function of that speed. Okay, so either through the captain on the rudder pedals with 6 degrees of travel in either direction, left or right, or you can have it through autopilot. So yaw controls there. Okay, so the nose wheels are automatically centered under the action of cams and the shock absorber. This is after takeoff. Okay. All right, so kind of a thing to note here, we get a steering angle limitation, but here it's a function of the speed of the aircraft and also the origin of the input. So for example, if the aircraft is higher than 130 knots, then the steering's not available. If for some reason, or if we have ice on the runway, then the pilot can it's decided to disconnect that control by operating the pedals. Okay. Okay, so the maximum, and just on the maximum towing angle, just so you know, is plus or minus 95 degrees on that. All right, and as far as nose wheel steering, we are still getting our supply from the green hydraulic pressure that's going into a hydraulic block when we have the nose gear extended. Okay, and the doors are closed. Essentially, we're talking about after we have a free fall extension of the gear. So let's say we have a free fall extension. When the doors normally remain open, then we have the steering control is lost on that. In that case. Okay. All right, and then of course in flight, after the gear is extended for, coming in for a landing, then that's when, the steering control can be tested. Okay, so as far as that goes, the test is going to start 10 seconds after down lock, and it stops at touchdown of the main gears. Okay, and just kind of a little bit on the actuating cylinder, the steering actuating cylinder. This is part of the nose gear structure. You've got this located on the nose landing gear strut. Okay, then remember I mentioned the hydraulic block. So you do have that hydraulic block that's attached to the rear of the nose gear strut. And so what comprises that hydraulic block I mentioned earlier? We have a filter, you got a check valve, there's a bypass valve, you also have an adjustable diaphragm and a servo valve, the deflection jet type. So you have those things there. Okay. And you also have an anti-shimmy accumulator. Okay, there's also a feedback sensor. There's 2 of them. There's sensor boxes. There's 2. They're exactly the same. And what are they? What's its job? Sensing is sensing what? Okay, the position of the rotating tube. Okay, of the nose wheel steering. And those sensors, again, those signals are going to the BSCU. The box itself, it's a gear assembly. with this sensors, sensor housing there. Okay, so kind of give you an idea with the picture there, but there's the gearbox at the top, and then you can see the sensor. Okay, you got that feedback at the bottom, steering feedback. Okay. Okay, you also have a swivel selector valve. This is installed with respect to the landing gear retraction axis. Okay, so what does that mean? Okay, it means that when the landing gear starts to retract, then the valve is going to cut the power supply and connect that hydraulic block to the reservoir return line. Okay, that's what the swivel selector valve does. It's located above the nose gear shock strut, and that's attached to the right trunnion. Okay, remember I had the main one that you can refer to. It had that. What location of the trunnion motion of that. So, and then what about temperature? Temperature is very important. You know, we talk about pressure and temperature all the time. The temperature of the brake system, you know, we want to make sure we keep that in check, that we're monitoring to make sure it doesn't get too hot. So we have temperature sensors, and we've got the monitoring units as well, of course, as the control, you know, the BSCU that we have. So, you know, what's important here when we're looking at temperature, we get, you know, the highest temperature that you can read that has a green arc above it is greater than 100 degrees Celsius or 212 degrees Fahrenheit. So when you have a temperature that exceeds that threshold, then it's going to show an amber, right? And then also the difference between the temperature of two brakes. If that's higher than that 100 degree, you know, Celsius or 212 degrees Fahrenheit, it increases the brightness of that indication of the hottest brake. So that's the indication on the display. Okay, so all right. And then the temperature sensors, okay, so those are located on each brake, and they're housed in the torque tube. Okay. All right, so that covers that. I'm going to add a little extra to this. This is since it's our last session. I know we covered some things. I want to just kind of re-emphasize a little bit more on the landing gear indicating and warning, just to reiterate. I know I covered this before, but just some of the, again, kind of a recap, if you will, because it's important to know what's on the wheel page, you know, of the eCam. And so, you know, again, just kind of revisiting here. But here, you know, we got this, the CWS, obviously the eCam as well, and showing, you know, indications of there for position. And, you know, so when we talk about the wheel page, okay, shows position of each landing gear and its door. And it's going to automatically show when. Remember I mentioned that before, but okay, when the first engine starts until the first engine gets to takeoff power. Okay. Another condition is the landing gear is selected in down or the 1600 feet radio altitude until the second engine is shut down. Okay. All right. Okay, so it's kind of what I just wanted to get you to kind of get remembrance of back on the eCam wheel page and what shows there. You got your two triangles, you got hinged bars, okay, that shows that the door, hinged bars has to do with the door positions. Okay. All right, so this concludes session 6, and we're going to have probably more knowledge checks. Again, just go over, you know, definitely refer to the handouts that have those questions, because again, a lot of those are going to be test questions, so just review those when you have a moment. And if you have any questions, of course, you know, definitely reach out to us through email. All right, so that concludes session 6.